Can it be extra credit if we do the homework?
No. Let's just skip it.
No.
We're just skipping it, okay? So,
Wait, so,
let's start out with the vocabulary. Levi, what is an arithmetic sequence?
oh, it's a sequence where you add stuff.
Okay, how about going back to we're doing review, so how about going back to the lesson that had arithmetic sequence in it and reading me the definition,
Yeah, I can do that.
okay?
On the other chapter. Okay. An arithmetic sequence is a sequence of numbers, each differing by a constant amount from the preceding number.
And that, okay, good. And what is that difference called in an arithmetic sequence, Jacob?
Common difference?
The common difference. Did we start video? Okay, thank you, Olivia. Okay. Okay. So, Eric, what is the common ratio? So I suggest that if you're not sure, that you look at the page on geometric sequence, which is going to be after the one that's on arithmetic sequence. On page 158, under definitions.
The constant multiplier for a geometric.
No. What is a geometric? Oh, the common ratio, yes, the constant multiplier,
For a geometric sequence is called the common ratio.
common ratio, R. So that's what we multiply a position by to come up with the next number, right? Or if we're building an explicit formula, that would be for a recursive formula. If we're building an explicit formula, it's the R that we have in there. So in either formula, it's the R, okay? So, Jake, what is a composite number?
Composite?
Jacob, slide back further, please. Further than that, please. Thank you. Jacob, remember we learned about prime and composite numbers.
Any natural number greater than one that has a positive factor other than one in itself is called a composite number.
That's right. So prime number only has one in itself, and a composite number is everything that has more than one and itself as factors. Okay? So the simple thing, like for prime and composite, and I'm not trying to say that composite numbers are bad, but it's like good and bad, right? The real test for good and bad is really to say, find out what is good, right? And everything else is not good, right? The definition of good, right? Who was the embodiment of good on earth? Anybody?
Jesus.
Jesus, right? Right? And guess what? Everybody else is not who?
Jesus.
Jesus, right? Right? The Bible tells us there's only one who's good, right? So, same thing here, right? You can look and say, okay, well, prime numbers are easy to define. Two factors, one and the number itself. That's a prime number. Anything that has any more factors in it, for example, like the number 9, it has the factors 1, 3, and 9. Slide your chair forward, please. 1, 9, and 3. Okay? So we added a factor, and because of the fact that you add a factor, it is now a composite number that you're looking at. Okay? Now, we had recursive formulas and explicit formulas. Okay, now I know we had them for both the arithmetic and the geometric. We had them both in problems where the main operation was addition, and we had them in problems where the main operation was multiplication. But there is a pattern to them. Even though you have recursive arithmetic and recursive geometric and explicit arithmetic and explicit geometric, there is a pattern, right? The recursive based off previous position. Right? So on a recursive formula, if I have 2, 4, 6, 8, well, the next number is 10, and I'm going to base it so it's a n minus 1 plus 2 equals a n. This is 8, this is 10. I'm basing it off of the previous one. When we do it in a geometric one, it's the same thing, but instead of adding a number, I'm multiplying by a number. And we just look at the previous number. With an explicit formula, it's based off A1. We look at the first number in the sequence when we do an explicit formula. Then we build based off of the difference for arithmetic and the rate for geometric. Okay? So we have recursive and explicit for both arithmetic and geometric. And you need to understand that. So you have arithmetic, geometric, okay. And we have recursive and explicit. And we have both for both of them. Okay, so don't think that recursive might be arithmetic and explicit is geometric. Right? You have both types for both of them. Okay. Ethan, what is a factor?
A factor is a number that you use to multiply another number to get a number.
Right, so a factor is a number that when multiplied by another factor, those are both called factors, you end up with a What's the result of a multiplication problem?
Answer?
It's an answer, right? But for addition, we end up with a sum, and multiplication, we end up with a,
Multiple?
it is also a multiple. That's very good. And that's very important with understanding the difference between factors and multiples. It's also called the product, right? Factor times factor equals product. But for this chapter, actually, it's very good to understand that factor times factor equals multiple, right? Because we need to distinguish between factor and multiple because we're trying to find greatest common factor, least common multiple. Okay, we got that? Right? So that's a factor. Olivia, do you want to tell me what a geometric sequence is? And again, you can read it right out of the book and know where it is, and then make sure you can study that.
It is a sequence of numbers whose successive terms differ by a constant multiplier.
Constant multiplier, that's right. And Diana, what is that constant multiplier called? So for arithmetic, we had D as the difference, right? And for geometric, R, that's right. Very good. R, right? This is difference. And this is ratio. Or the common ratio, right? So, Levi, back to you. What is the greatest common factor? How would you define that?
The greatest common factor is a number in which two numbers. It's the greatest number, or it's the greatest factor of two numbers.
That is correct.
If that makes sense.
It does. It does. Let's see what the book says. Right? But that is correct. That explanation is correct. It is the greatest factor of two or more numbers, because you could have the greatest factor of three different numbers, for example, right? The greatest common factor is the largest number that is a factor of all the given numbers. So it could be two numbers, it could be three numbers, right? It's the largest number that you can divide into all of the numbers that you're looking at, right? So, Jacob, what is the least common multiple?
The lowest multiple of two numbers.
The lowest
Multiplied by themselves.
of two or more numbers that you're looking at, right? It's the lowest multiple of two or more numbers. Okay, again, we've done it before, we'll look at it again. Factors, we'll just pick out a number of 8. Factors of 8 are 1, 2, 4, and 8. Multiples of 8. 8, 16, 24, 32, right? And it should make sense that 8 is in both sets. Right, because 8 times 1 is a factor, so 8 is a factor. 8 times 1 equals 8, right? And because 8 times 1 equals 8, 8 is also a multiple of 8. Okay? Please concentrate on this, right, when you're studying, so that you know the difference between what is a multiple and what is a factor. Okay? prime number we already defined, recursive formula we already defined, relatively prime. Eric, do you know what relatively prime is?
Does that mean there's,
You're starting out well.
the, one in itself can only go into that number?
No,
Or is that
that's
just
prime, okay,
Okay.
but you're on the right track. The only common factor between two numbers that is relatively prime is the number.
one?
Very good, alright. So, a great example of relatively prime is right? We can do 9 and 25, for example, right? 9 breaks down to 3 times 3, 25 breaks down to 5 times 5. We can add 16 to this group, right? And that breaks down to 2 times 2 times 2 times 2. That's a relatively prime group. There's no factor that you can find that's common to 9 and 25 or 9 and 16, right? That, other than 1. And also then any two consecutive numbers, so let's take 8 and 9, or 2 and 3, or 24 and 25. These are all relatively prime, meaning 8 and 9, not meaning 8 and 24, right? But those are all relatively prime sets. Okay, so Levi and Jacob, I need to see both of you.